Hey gang, take a moment, pause the video, copy this down. I'm going to reference it quite a bit. Did you pause the video? Did you copy this? You'll need this down. As we move forward, we're going to be writing angles in standard position and also finding coterminal angles. So these two things are called the unit circle, which we use a ton, and they help us make a reference to the types of degrees we come across normally, but also the radian measures that we come across. And as we deal with circles and we deal with these angles, they have a certain fashion where if we're dealing specifically with positive angles, we're always going to start towards the right at this 0, 0 mark, and we're going to go counterclockwise, which seems kind of odd, but that's how this works. So if we were dealing with 90 degrees and trying to show this on a circle, we would take the 0, 0, or 0 degrees or 0 radians. We would then follow this along until we hit 90 degrees, or pi over 2 in radians. And then this would be considered the visual of 90 degrees. If we deal with negative angles, the situation looks pretty similar, but now we go clockwise. So we start still at 0 degrees radians and degrees, and we would then go clockwise. So if they asked us to find negative 90 degrees, it's not quite the same as over here. Negative 90 degrees would go down just like a clock would, and then curve back around. So as we see here, we're being asked to go to radian or degrees and map out where this would be in standard position. So personally for me, I always try to write in a few things. I try to write in the 90 degree mark, 0 degree mark, 180, and 270. And since we're in radians, we saw in the previous section that we can go back and forth from radians to degrees and vice versa. So I personally think that's the easiest approach, unless you want to try and memorize how all of the radians work around here. They pretty much just cut up terms of pi and then set the pi equal to 180 as far as radians and degrees. Yeah, I know it's weird. Trust me. So with this, I'm just going to go to degrees. So we have 3 times 180 over 2. So if we have 540 over 2, this can be rewritten as 270 degrees, which would be down here. If we were going for 5 pi over 4, you might also get comfortable enough with the unit circle where you can break this up and recall that this would be pi over 4. This is 3 pi over 4, 5 pi over 4. So 5 pi over 4 would be in between 180 and 270, so this would be 225. So that would be for 10. We can also go the negative approach where, again, we have to kind of map this out clockwise. So as soon as I see negative, I think, all right, we're going clockwise. So 5 pi over 3, well, if we divvy this up with pi over 3, that would be approximately 60 degrees. So that's one form of 5 pi over 3, then 120 would be, where is that at? I think it's here, yeah. So now I'm sketching out the thirds of this unit circle, which can be tough for sure, but let me keep this going. So if we're doing 5 pi over 3 and it's negative, we go past 1, 2, 3, 4, 5. So this is negative 5 pi over 3 for 11. And yeah, that should be good for the radian parts. The degree parts, you kind of have to map it out just like this. So 210 positive would be out towards here, 30 degrees after 180. Negative 120 would go about this fashion, and we're 30 degrees more, so we're about here. This must be 14. 690 actually loops around quite a bit. So 690 would go around 360, We're a little less than 720, so we'd be like right here, I think. That one's a little tough. I notice sometimes we go full circle when we do this, so think that out. It's a little tricky at first, but take your time with these. They're a little difficult, so if you have any questions, let me know.